Okay, 1.5a. Okay, so we're just going to go through all types of equations. Some of them will be really easy. So the first is a linear equation. Okay, for example, 2x plus 5, right? Anything that has a degree of 1. I'm assuming that you know how to solve any type of linear equation. So we're not going to do any of those. Okay, so that's one. The second type we're going to talk about is a rational equation. So this is where we're going to have, you know, like two fractions set equal to each other. So like 2x plus 4 over 10, let's say minus 5 equals 2x over 4x plus 2 is an example. So remember, when we were talking about rational expressions before, when we had those compound fractions, we were trying to clear the denominator, right? We would multiply through by the LCD to get rid of the fractions. Well, this is really the same thing. We're going to multiply by the LCD. So the steps for this, step 1, you multiply by the LCD to clear the denominators. So now our goal is to get rid of the denominator. Step 2, once you've done that, then you just, solve for x, which could be a very, various ways. And then step 3, you have to make sure that you check your solutions. So check for extraneous solutions. Alright, so let's try some of these. X over 5 minus x over 2 equals 3. Okay, so we have a rational equation. We want to try to clear the denominator. So you want to look at all of your denominators. Remember, 3 is like over 1. You want to look at all of those and decide on the LCD. So what's it going to be? 10. So I'm going to multiply the left side by 10 and the right side by 10. Whatever you do on the left, you have to do on the right in order to keep the equation balanced. So what I get here is 10x over 5. That simplifies to 2x. On my next term, I get negative 10x over 2, so that simplifies to minus 5x, which is equal to 30. Combine like terms. Divide by negative 3. X is negative 10. So it's not enough just to stop there and decide that you've solved for x. You then need to check your solution. So to check your solution, you have to plug it back in. So negative 10 over 5 minus a negative 10 over 2 hopefully equals 3. This gives us negative 2 plus 5, which is indeed 3. This is a good solution. Bless you. Okay, I don't have to see your check. You can do it in your head. You can do it on the calculator. I will know if you checked because you'll either tell me that the solution works, or if it's extraneous, you'll tell me it's extraneous. Okay, so you can check however you'd like. All right, let's try another one a little bit harder. 1 over x minus 2 plus 3 over x plus 3 equals 4 over x squared plus x minus 6. Okay, so we're trying to decide on an LCD here. In order to do that, we should try to factor this piece. Okay, see if it factors. So it does. factors to x plus 3 times x minus 2, which is good because those are the pieces I have over here, right? So we're going to combine all this and we're going to think about what's the LCD I need to multiply by in order to cancel each one of those denominators. So what's it going to be? X plus 3 times x minus 2. Okay, that'll cancel each one of them. So I'm going to multiply again on the right and the left. Okay, so remember, whatever's in common, that's what's canceling. So this x minus 2 cancels. We're left with 1 times x plus 3, so that's just x plus 3. In the second term, the x plus 3 is in common, so that cancels. We're left with plus 3 times x minus 2. Bless you. On the right side, both of those factors are in common, so that entire denominator will cancel, which is what we want to happen, giving us 4. This just became a lot simpler now. Okay? So we have to distribute, combine like terms. This gives me 3x minus 6 when I distribute. Combining like terms, I get 4x minus 3 equals 4. Add the 3, divide by 4, and you get x equals 7/4. Okay, now you'd have to go back and you'd have to plug it in. So 7/4 is going to go in everywhere you see an x in the original. Make sure it works. I'm not going to spend the time doing this. This one works. Okay? Maybe just make yourself a note. Don't forget to check. Okay. We're going to do one more of these. So C, 3 over x times x plus 1 plus 7 over x plus 1 equals 3 over x. I think you and your partner should try this one. So try it and don't forget to check your solution. Okay, so did you multiply by x times x plus 1? Okay, when you do that, that first denominator will cancel completely. You'll be left with a 3. The x plus 1 cancels in the second, leaving you with 7x. Here, the x is going to cancel. You have to distribute the 3. So this is a common mistake. Students will write 3x plus 1. You have to remember to distribute to both of those terms. So we should get 3x plus 3 there. Let's see. When you subtract the 3, you end up getting 7x equals 3. Subtract this 3x over, you get 4x equals 0. Divide by 4, and you get x equals 0. So my question is, when you checked this, did it work? No. What do we call this? Extraneous. Okay, so this is an extraneous solution. So when this goes in, right? It makes this denominator undefined. If it makes one piece not true, then the whole thing is not true, okay? So all you're going to do, you're not going to like scribble this out or, you know, so I can't see it anymore. I want to see that you got 0. You solved the equation correctly. It just doesn't work. So just draw a line through it, and you can just write ext next to it. Okay, so this is extraneous. Are there any questions on rational equations? Everybody okay if we move on? Okay, let's talk about the third type, higher degree polynomials. Okay, so when you have a higher degree polynomial, this is like x to the 4th plus 3x squared plus 2, say. Okay, equals, we'll just say equals 0. So when you have a higher degree like this, okay, you have to factor. So we're still going to factor these. We just have to, you know, kind of think about them a little differently. So the process here, I guess, is just to factor. We don't really need to write steps out, I guess. So just factor these. So let's try one. Let's say we have x to the 4th minus 4x squared equals negative 3. Anytime you have something with a higher degree, you want to bring everything to one side, right? In order to factor this, it's got to all be equal to 0. So I'm going to pull that 3 over. And I don't know what it is about that 4th degree, but it really makes students nervous, okay? So here's what I want you to do. Remember that thinking little column we got going on where we make things easier? Okay, so this is what I'm going to do instead. Instead of looking at it like x to the 4th and x squared, I'm just going to think about it like, what if this was x squared minus 4x plus 3? Do you know how to factor that? Yeah, it factors to x minus 3 times x minus 1, right? Still the same rules. It has to multiply to a positive 3, multiply to x squared, and then add to that middle term a negative 4x. Well, now let's just apply that idea over here. How do you get an x to the 4th? What do you have to multiply together? X squared and x squared. So that's where you start. I still have to think about what multiplies to a positive 3 and adds to a negative 4. So I'm still going to use minus 3 and minus 1. And now notice when I check that middle term, I have a negative 3x squared and a negative 1x squared adding to the negative 4x squared I need. Okay, so don't let this 4th power like freak you out. All right, just think about how would you factor it if it was a squared term, and now instead of x and x, write x squared and x squared. Okay, so now we have to solve these pieces. We use the zero product property, right? We set each of them equal to 0. Here we're going to get x squared equals 3, and x squared, oh, I kind of cut corners there. Let me write that out nicely. X squared equals 1. Okay, now when we were talking about simplifying radicals before, we would not write the plus or the minus in front of it, correct? That's because we were just simplifying. So now that we're solving, we have to use the plus or minus. Anytime you take the square root, we're going to have plus or minus the solution. So looking at this, this is going to give us x equals plus or minus root 3. And here we're going to get x equals plus or minus 1. It's not a bad idea to check these solutions. This is not a case where you're going to get a lot of extraneous solutions. If you check, though, I mean, it's just good practice, right, to know if you're turning in the right answer. So that's up to you. Those aren't mandatory to check. Any questions on that? So far, so good? We're going to talk about one more type today, absolute value. Okay. So an absolute value equation, you know, might look something like 2 times the absolute value of x minus 1 equals 10. Okay, so there are steps for this one. Step 1, you need to isolate the absolute value. Okay, so you have to get it by itself before you can start to solve. Step 2, you're going to create two equations from the absolute value. Step 3, you're going to solve, and then for absolute value you always have to check. Alright, so let's try one. The absolute value of 3x plus 7 equals 4. Okay, now let's think about this for a second. When you take the absolute value, you're really talking about the distance away from 0. Okay, so that's why it always comes out positive. So when you have the absolute value of 2, you get 2. When you have the absolute value of negative 2, you get 2, right? So now keep that idea in mind. So the first step is to isolate the absolute value. Well, it's all by itself, right? So we're good there. Step 1's done. Step 2 says that you have to create two equations. Now there's two ways to do this. Some people like to change the outside. Some people like to change the inside. It's up to you. So the first thing you do is you set up exactly what you have. So you just take the absolute value away and you end up with 3x plus 7 equals 4. At that point, to create the second equation, you have a choice. You can either change the inside so that it says negative 3x minus 7 equals 4, or you can change the outside so that it says 3x plus 7 equals negative 4. For me, when I think about the absolute value, I think about what's on the inside. So whether it's positive or negative, it's going to come out the same. So for me, I always change the inside because I think it applies the rule of absolute value. If you don't want to change the inside, don't. Change the outside, okay? If you set up your second equation as 3x plus 7 equals negative 4, you would get the same answer, okay? So it's your choice. And then you solve. So I get 3x equals negative 3, so x equals negative 1. Over here I get negative 3x equals 11, divide by negative 3, and I get x equals a negative 11 thirds. Now, with the absolute value, you always have to check your solutions. I don't care if you just plug it in and check in your head. That doesn't matter to me. So if I do that, if I plug in a negative 1 here, I get negative 3 plus 7, which is 4. Absolute value of 4 is 4. This is a good solution. If I plug in negative 11 thirds, I'm going to get those 3's to cancel. I have negative 11. Negative 11 plus 7 is negative 4, but when you take the absolute value, it becomes positive 4. Both are true solutions. Both are good solutions. You can, circle them separately, or you can list them from least to greatest. Either way. Okay. We have one more. How about the absolute value of x squared minus 6 equals x? Okay, so again, step 1 says you got to isolate the absolute value. That just means, like, going up to the first equation I wrote, you'd have to get rid of the 2 first, okay, before you can do anything. But that's not the case here. The absolute value is already isolated. So now we're going to set up our two equations. So the first one is exactly what you see. The second one, you can either change the inside signs or you can change the outside. It'll come out the same. I'm going to change it inside. So I have negative x squared plus 6 equals x. So this is a case where I have a higher degree of 1, so I need to get everything to one side and try to factor. So I have x squared minus x minus 6 equals 0. Here I'm going to bring the x squared over to the right side instead. I don't like a positive or a negative x squared. So I have 0 equals x squared plus x minus 6. When you factor, you should get x minus 3 times x plus 2 equals 0. The second equation, x plus 3 times x minus 2. Oh, I already have it equals 0. Using the zero product property, I come up with the solutions of negative 2 and 3 for the first equation and negative 3 and 2 for the second equation. So right now I have 4 solutions, plus and minus 2, plus and minus 3. You have to check these solutions. So we have to check every single one of them. So I'd like you to try to check them now. So whether you do it in your head, you write it out, you use a calculator, I don't care. Just check all 4 of those solutions and see what you come up with. Which ones don't work? -2 and -3. Did you really have to take the time to plug that in to see that it didn't work? No, because we have an x over here, right? Is there any way to take the absolute value of something that's isolated and get a negative answer? No. So right away we should have been able to recognize that these 2 solutions are not good solutions. Those are extraneous. So the only solutions I have here is x equals 2 and 3.